Good morning, students. Welcome back to the momentum transfer class. Today we'll be discussing about manometers and how to measure the pressure difference. In general, the manometers are used to measure the pressure differences in any pipe or any equipment, right? So, the manometers are generally used in orifice or venturimeter where we can measure the pressure differences. So a simple YouTube manometer will look like this, right? So where you have fluid A is the manometric fluid, generally used as mercury, and the density of fluid A is rho A, and there is a fluid B which is comes from the pipe or the equipment where we need to measure the pressure difference, and the density of that fluid B is density rho B, and the pressure in the left leg is PA, and the pressure that is acting on the right leg is PB, and ZM is the height from the top to the right side leg where the fluid manometric fluid starts, and ZM plus RM is the height from top to the again manometric fluid in the left leg, right? This is the simple YouTube manometer and the nomenclature of it. So when you want to know how to measure the pressure difference, right, we should use the hydrostatic equilibrium condition, right? So hydrostatic equilibrium condition is nothing but the force balance. So let us write the force balance to know the pressure differences, right? So when you come back, so you should write the force balance, right? So force balance. So what is force balance here? PA into S plus, because the left leg I am writing, the pressure acting on the left leg into the cross sectional area of the manometer, plus we have G into Rm plus Zm, that is the total height, right, into, right, what is G Rm plus Zm into cross sectional area, right? So this is area into volume, so it is mg into density. What is the density? Density of here it is rho b, right, is equal to PB, that is right leg I am writing. So PB is the pressure on the right leg into cross sectional area, plus GZM into cross sectional area into rho b. Zm is the height in the right leg manometer up to the interface, right, into cross sectional area into density of the fluid, plus G Rm into cross sectional area into rho A. So why there is a difference like this rho B and rho A is because up to Zm we have fluid B, so that's the reason why I am writing density B, and from Zm point to Rm the liquid that is being acted is rho A. That's the reason why I wrote it separately here. But on the left leg, if you see, you have the entire liquid, that is the region Rm plus Zm is covered with density of the fluid is rho B. So that's the reason why I wrote it like this, right? Now we can cancel off the cross sectional areas wherever we have, because everywhere it is there, right? And then we separate them, the pressure terms, we write it on the left hand side. So PA minus PB is equal to, I write these terms the same as it is, GRM rho A, that is this two terms I wrote, and this term I should take it to the right hand side, so it becomes minus GRM rho B right? I'm separating it, minus G Zm rho b, right? Now if you have any common, you can cancel it off. So this and this term is cancelled out because G Zm rho b, G Zm rho b, it is minus in place, so we can cancel off. So we are left with this Grm. Grm is common, so it is rho a minus rho b. So if I write it, so this becomes PA minus PB is equal to Grm into rho a minus rho b. So what is this? The pressure difference in a manometer is given as gravitational force into Rm. Rm is the distance between the two fluids, that is in left leg and right leg. What's the difference? Into density of the manometric fluid and the measuring fluid. This is the expression to calculate the pressure in a manometer, in a simple U-tube manometer, right? So I hope I am clear. So if you see this figure is called as inclined manometer, which is used to find the pressure differences when they are very, very, very small, right? So sometimes there are a few applications where we have to measure a small difference in pressures. Then we need to have this inclination, that is one leg is vertical but the other leg is inclined, right? So if you can see this, the angle with the horizontal is alpha, right? And now what is happening, if you want to see this, the difference is this Rm is very less. But if you measure like R1, that is in an inclined position, this will be more. So it is very easier for us to measure this distance. So the equation will be changed a little, that is this. PA minus PB is equal to G. Instead of Rm, I write R1 sin alpha into rho a minus rho b, right? So I replace Rm with R1 sin alpha. That's it. That is the only change we have for an inclined U-tube manometer, right? That is the difference between a U-tube manometer and an inclined manometer. Let us see an example such that it will be easier for you to work on, right? Yeah. So the problem number 2.1. So a simple U-tube manometer is installed across an orifice meter. The manometer is filled with mercury. Specific gravity is 13.6. Usually for chemical engineering problems we use specific gravity rather than density. So what is specific gravity? Specific gravity is nothing but density of any fluid to the density of water. Density of water is 1000 kg per meter cube, right? So if you want to find out the density of any fluid, that should be multiplied, that specific gravity must be multiplied with the density of water. That's it. And the liquid above the mercury is carbon tetrachloride, whose specific gravity is 1.6. The manometer reads 200 millimeters, that is Rm is given as 200 millimeters. What is the pressure difference over the manometer in newtons per square meter? He is asked in a specific unit, right? So let me take you to the problem. So I have written here. So first write the given data. So the given data is specific gravity of mercury is given as 13.6. To get density, you should multiply with 1000, so it becomes 13,600 kg per meter cube. And density of B is 1.6, right? Specific gravity is 1.6. So if you want the density, you should multiply with 1000, so it gets 1600 kg per meter cube. And Rm is given as 200 millimeters. I need to convert this into 0.2 meters, right? Then what is the pressure difference formula? Pressure difference formula is G Rm rho a minus rho b. So it is PA minus PB is G is 9.81 into Rm is 0.2 into 13,600 minus 1600. So when you do this calculation, you will get the answer. Answer I am not telling you because you can calculate this. So this will give you the pressure difference in this manometer for. So it is as simple as it is, right? It is directly substitute. First, for any problem, you should write the given data and identify the correct equation which I should use. Then you can easily substitute and you can get the answer. So that's all for today. So we'll meet you in the next class. Thank you.